All right, guys. So today we're actually going to be talking about scientific notation. It is absolutely important that you have a calculator out with me today. I do not care if you are at home and it's like, yeah, I'm just going to watch this lady and I'll be like, yep, I can do that in my calculator. Absolutely not. You need a calculator today. Now, in my class today and moving forward throughout the whole year, you can use either a graphing calculator, which I'm pretty sure most of you guys already have for your math classes, so that's what I'm expecting to see. Or you can even use something a little bit simpler, something we call a scientific calculator. I have no clue what these look like nowadays, but this is from, I don't know, 25 years ago. She still works, so we love that. But basically, you just need a calculator that is able to represent numbers in scientific notation, doing like exponents and stuff like that. Your standard, just little like child's calculator is not going to give you that function, so we're looking for this. For the most part in our class, you need to have that calculator handy with you every single day. So make sure that you guys are on top of that. But whatever calculator you have, that needs to be out and handy, okay? All right, so let's talk about scientific notation. We love this. Okay, in this modern age of exploration, what are scientists wanting to discover and learn about? Well, our technology has gotten pretty good that we've kind of roughly discovered and learned most about the observable world around us, right? The things that we can see. But with like telescopes and microscopes and all of this other crazy stuff that I do not even understand, our focus nowadays as scientists are diving into the very, very, very small, like the quarks and the strings and stuff like that. And then also on the other side, diving into the very, very, very large, like all the space stuff that I do not understand. But those are going to need really big numbers versus the small things are going to need really, really small numbers. So when we're measuring things that are really big or small, things get a little bit hairy. We've got to come up with a better way to represent these numbers. So like I said, currently research in science is focused in areas concerning the microscopic world, atoms and molecules, and even smaller than that, and the macroscopic world, which is outer space stuff. As a result, it's very common for measurements to be either very small or very large. Scientific notation is the way that scientists easily handle very large numbers or very small numbers. For example, instead of writing, whoa, that's a lot of zeros, my hand is tired looking at that, we're going to write 5.6 times 10 to the negative ninth. So who determines that negative ninth here? That negative ninth in some way represents how many places you are moving the decimal to get from scientific notation into the original place. Now, we just talked about metric conversion, and that is all about moving decimals. And I find if I have too many topics where I'm like, we move the decimal for this way, and then this way, and that is the rule, I get confused. Specifically with the dynamic between measurement in the metric system and now with scientific notation. So what I find helps me is I look at the exponent number and I ask myself, is that a negative number or a positive number? And whether or not it's negative or positive means something to me and then guides my brain to figure out, okay, well, that means I need to move the decimal this way. We already talked about how I get left and right confused. I just focus on which way we're moving. Okay, so what I think about is I say if you are a big number, meaning if that original number, if I popped it out of scientific notation, is a giant one, probably with a lot of zeros coming at the end of it, it's going to be having a positive exponent. Okay, on the other end, really, really, really small numbers, like this one right here where you got a decimal and then a blast full of zeros coming at it, those small numbers are going to be represented by negative exponents. I like to think about it like football players, right? Being a big guy on the football field is positive. That's a good thing, right? But being a small guy on the football field, that could be kind of a little bit of a disadvantage and negative. So that helps me kind of categorize my brain to where I do not get confused because there are a lot of things already in my brain and I do not have the time and space to really make it more complicated than that. Okay, so with that being said, we're going to take these numbers out of scientific notation. I have already noticed that, oh my goodness, that 3 is a positive number. Positive things are big. So that means I am going to move my decimal 3 places in the direction that will make that number bigger than what it is. So I cannot move it this way. That would make it stronger or smaller. That is not what we want. So we're actually going to move it 3 places that way, right? So I would go 1, 2, 3, and fill in the rest of the places with 0. So this number, if I were to take it out of scientific notation, would be 8, 4, 5, 0. Yes, and a great way to check is you can go back to your exponent and be like, great, that was a positive exponent and we got a big number. I moved my decimal the right way. Okay, next one. I got 10 to the 9th positive. We are making this number bigger than what it is. I got to move this 9 places this way. So I'm going to write 4, 9, 8, 7. To get that far, I had to move 1, 2, 3 places out of the 9, which means I need to add 6 zeros to complete that full 9 run. So 1, 2, 3, 4, 5, 6. Yes, once again, these big numbers are represented by positive exponents. Okay, so here's the opposite. My small numbers are represented by negative exponents. So here I have a times 10 to the negative 8th, which means I gotta make, because of that negative sign, this number needs to be smaller than what I see in its scientific notation form. So I have to move it in the other way so that decimal gets as far away as possible from it and is followed by those zeros that is characteristic of these small numbers. So I gotta move it 8 places this way. So 1, 2, 3, 4, 5, 6, 7, 8, right? So that decimal is going to end up way over here with 7 zeros and then 8, 4, 5 at the end. So 1, 2, 3, 4, 5, 6, 7, 8, 4, 5. One thing I'm going to give you a heads up about, sometimes you'll get a little bit freaky and like think you see this and like, great, it's just that number with 8 zeros in front of it. No, it is not, okay? You got to make sure you are accounting for that place of that first digit that's in the ones place for that scientific notation. Sometimes I get in the habit of just seeing whatever that exponent is and being like, okay, that means I would need 1 fewer than that number zeros in front of the rest of my digits there. Okay, and like we talked about last time, if you want to put a 0 here in the front, that is cute and fun and it looks really nice, and it is not changing this number because once again the decimal has not moved. It just makes it prettier to look at and easier for me to see what that number is looking like. Okay, cool. So we have a negative 4. Once again, negative. I got to make this number smaller. Football players are, when they are small, that's a negative thing. So I go 4 places this way. 1, 2, 3, 4. So this leaves me with 3 zeros and then the rest of my number. So I have decimal, 1, 2, 3 zeros, and then 4, 9, 8, 7. Yeah, look at that. We love that. That's fun. So now we are going to, over here, put numbers into scientific notation. Now this is why I get confused with the decimal thing, because the rules on which way you move the decimal over here in my brain, like I cannot swap it and translate it. That's why I hang on. Big numbers are positive, small numbers are negative. Okay, so the key thing here is that I have to move the decimal from where it currently is in this number until it lands just behind or to the right of the first significant digit. And when I say significant digit, I mean a number that is not a 0 here. And you can kind of check on all these examples over here. I have just one number and then a decimal and then whatever else is required. Like one number and then the decimal and whatever else is required. So you're going to this first example right here, and we got to move that decimal to right there in between the 1 and the 2, right? Because that would give us that one number that is in front of the decimal. Okay, so now all we have to do is we just got to get there, right? So we know our decimal, be him invisible, is over here. So I now have to count with my very old eyes. 1, 2, oh man, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm hoping y'all got 11 too. Otherwise, you guys know better than me. We moved it 11 places, right? So first thing I'm going to do is I'm going to write that beginning part of my scientific notation. Yeah, once again, I'm looking for only one number there, right? But I have to see somebody in the ones place followed by only the other significant numbers. You do not put those zeros there. We will talk a little bit more about the weirdness of significant numbers. We're going to hate that lesson. But for right now, we're just putting numbers that are zeros here, okay? Okay, now we blast in the times 10 to the, and then that exponent is going to represent how many places I had to move the decimal. And this is where you get weird and confused. Like, oh, is it a negative because I was moving that way, or a positive? No, remember, big numbers are positive. Small numbers are negative. That was a big number, right? So we are going to give him a positive exponent for those 11 places that we moved it. Cool. Ooh, this is fun. Okay, so now we're going to the next one. Cool. All right, once again, the decimal is starting over there. I need to sneak him where he is just behind that first non-zero number. So he's going to end up going right here behind that 4. How many places does it take for him to get there? 1, 2, 3, 4 places. Okay, so we will write our 4.25 times 10 to the, is this negative or positive? Big is positive, small is negative. That is a small number. When I mean small, I mean a number that is smaller than 1, right? The decimal comes in front of usually a bunch of zeros and then whatever is left, right? So that's a small number. Small is negative. So not only did we move 4 places, this is times 10 to the negative 4. Cute. Okay, I'm excited. So here we go. We have a decimal that's over here who is invisible, and we want him to move him to the first, or right behind the first significant digit. So that would start off by 6.79 times 10 to the, how are we going to get there? Let's count. 1, 2, 3, 4 places. We moved 4 places last time, but this time it is different because I have a big number, and we know a big number is positive. Big guys on the football field, that's a positive thing for the team. All right, this one, y'all get a little bit freaky when the numbers are like not big or small. 12. Wouldn't be necessary to represent the number 12 in scientific notation, but I like to be funny and like trip you up sometimes, but it's not that big of a deal. Still just got to move that decimal to 1 place behind the first significant digit, which is going to be right behind that 1. It's starting behind that 2. I am moving it 1 place. That's okay. Not a big deal. We go 1.2 times 10 to the, I moved it 1 place. Well, is it positive or negative? Big is positive. Small is negative. Well, it's definitely not small. It's not big, but it is a number that is bigger than 1. So it's going to be a positive exponent of 1. That trips y'all up. Here's another one that always trips you up. Great. Put this number in scientific notation. Well, in scientific notation, you have to move the decimal till it's 1 place behind the first significant number, which it already is. Do I need to move that decimal at all? I do not. So, you will probably never have to do this, but it may pop up on a quiz because I like to trick y'all guys sometimes. If I have not moved the decimal at all, if I've moved the decimal 0 places, then you say times 10 to the 0. Which I'm forgetting my math skills, but I'm pretty sure 10 are a number raised to the 0 power. Isn't that just 1? That may be completely wrong, but this is the correct answer. Because, yeah, I think that's correct. I'll have to look that up later and then maybe edit this video, or maybe not because I will be lazy. Okay, so here are some practice examples that I'm going to let you guys knock out on your own, probably for homework. Do you want to reference the homework assignment that also incorporates the metric conversions? On the back of that page, we have putting numbers into scientific notation, a lot of practice for you guys, and taking numbers out of scientific notation. So that's going to be excellent practice for you guys. Remember, guys, big numbers are positive, small numbers are negative. One thing, if you are an honors chemistry student, you're going to hang in right here with me on the video. If you're an on-level kid and you're like, man, I like a good challenge, you can do this too. That sounds great. That sounds fun. But we're going to practice typing numbers in our calculator in scientific notation, okay? Now, y'all are probably used to, now here's the dumb thing about my calculator. Oh my goodness gracious. So this is probably the calculator that all of you guys have. Unfortunately, underneath my document recording screen, like you cannot see anything. Well, you can kind of see it. It's okay. Regardless, I got my big old clunky one. Y'all, this is from like 1995. She still works though, and that may be easier to see, so we're going to see what happens. Okay, so the key thing here with typing numbers in scientific notation, you can type in open parentheses 5.4 times 10 to the little caret to make an exponent 4, close parentheses, plus open. That's a lot of typing in your calculator, and I don't know about you guys, like sometimes my fingers get like too fast and like I will miss something and totally get a wrong answer. There's a function in your calculator called the EE button, and I'm going to show you guys where that is right now. It is, there it is right there. It is a function that is activated first by hitting the second key. So to get the EE button, you're going to have to press second and then do that. And I'm going to show you what the EE button will actually do for you. So if I had a number like this, 6.0, you can see this, yep, 2 times 10 to the 23rd, which is one of my favorite numbers because that is a chemistry number of the mole. We love that. That if I were to type that into the calculator, the EE button actually takes the place of times 10 to the, which means you will blast into your calculator 6.02 E, and then just whatever the exponent is, 23. There is no times, there is no 10, there is no caret symbol. And the cool thing about this is that your calculator will know that all of that is together. I don't have to worry about like orders of operations or parentheses or anything, which then means when you type in something that's a calculation with these crazy scientific notation numbers, you just do that plus 2.2 E7. And your calculator's like, yep, got it, understand what that is. So let's practice doing that right now. Let's see if my calculator is going to do what we want it to do. I'm trying to figure out how I want to organize this. Okay, so here we go. We go 5.4. That's difficult to see. It's difficult to see. I'm going to use my old one because I feel like we don't want our brains to burn. Okay. Oh, look at that. That is so nice. We love that. Okay, so we're going to go 5.4, and my button, even though she's from 1995, still exists, so I go E. Now, I think this is kind of weird and bogus. Like, the symbol on the calculator is 2 E's, and when it shows up on your screen, it is 1 E. I don't understand that. That is okay. But then I'm going to knock out exactly what that component is. It is a 4. Cool. There it is. Now we're adding these two numbers together, so I just go plus. And then I go 2.2 E, and the exponent for that number is a 7. Yes. Woo! We like that. Now, in the directions, which I did not actually read, because I should also maybe focus on reading the directions to you have two choices. If you're feeling kind of uncomfy with this, you can totally write that number out on your page first to where you can physically feel like you can move the decimal to where you need it to be and then write it in scientific notation. I do not care. If you want to do it directly on your calculator screen, keep in mind just to put this number in scientific notation, we've got to move the decimal to where it's right here behind that first 2. So I'm going to write 2.2, and then I've got to continue on and write everything else that's not a 0, because as we'll learn later, that's a significant value. And then however many places I had to go to get to that spot, I'm going to have to count, right? I go 1, 2, 3, 4, 5, 6, 7 places. Is it a -7 or a +7? Well, that is a big number, so big is positive. We put a 7 there. Yes, and I did a lot of cutesy fun things on this page. Like this one, I just took away the parentheses. I just kind of a math visualization of different ways that we can see these numbers represented. Like here in this example, I actually showed the multiplication sign. But in this example, there's nothing in between those two numbers, but they are snuggled in real tight. I hope you guys remember from your math classes, that's understood that those numbers are being multiplied also. Here, this is one way to represent division. I could also put the numbers side by side with a division symbol in the middle. All this stuff is excellent, good practice for you guys. But keep in mind that, oh my gosh, this EE button is going to save your life, okay? It's going to prevent those sloppy mistakes that we hate. And I think that this is going to be amazing. So you guys have some practice problems. If you are an honors student, you will be tackling these two problems here at the end. One thing I am going to write on here for right now, I do not want you guys to freak out too much about how am I going to round this number? Am I going to round this number? That is a conversation for next week, which you're going to hate. But for this page only, I feel like we already have a lot going on here for y'all to worry about. So for this page, we are don't worry about rounding ... yet. I'm going to put a smiley face to trick y'all and be like, it's going to be fun next week, I promise. Anyway, so that's my lesson on scientific notation. Remember, big numbers are positive and small numbers are represented by negative exponents.